Lesson 12.9, convert between degrees and radians. Up until now, we've always been in degree mode on our calculator, and I always tell you to check the mode because when you get farther into math, we do a lot with radians, and that usually includes pi in the answer, and it's just another way of expressing an angle as a different measurement, kind of like feet and meters or kilometers. They're all just different ways to express the same amount. So the first thing I'm going to have you do is a couple of these where it's kind of guided, it's more visual to help you see what you're trying to do. But it says, what fractional part of one semicircle does the labeled angle represent? Express your answer as a fraction in simplest terms, then express the labeled angle in radian measure. The main thing you need to know is that a semicircle, so this would be 0 degrees if it was just no angle, a semicircle is 180 degrees, or it's also pi. And so that's why we're comparing everything to a semicircle, because one semicircle equals 1 pi. And so if I can take the degrees, like 105, I can figure out what part of pi that is. So I'm going to say it's 105 degrees out of 180 degrees in a semicircle. And I need to simplify that, and the fastest way would be to get on your calculator and do 105 divided by 180, which will get me a decimal, hit math, enter, enter, and so really that's 7/12 of a semicircle. And if you come over here, I like that it shows you in the answer, once you submit that it shows separating a semicircle into 12 pieces, and it has 7 of those 12 shaded in, because really you're dividing these numbers by 15 to simplify. And so then all they want here is saying, okay, well, what's the angle measure in radians? It's 7/12 of pi. And so I put the pi in the numerator, because if I have 7/12 of pi, pi's over 1, so it'd be 7 pi over 12. So basically you're taking the fraction from here and just tagging on a pi in the numerator. It's 7/12 of pi. It's 7/12 of a semicircle. All right, number 2, I picked an example that's almost a complete circle. And so we're going to get an improper fraction where we have more than a semicircle, more than pi. So we should get a big number on top of a smaller number. And so I'm going to do the same thing where I take 335 degrees out of a semicircle, which is 180. I'm going to put that in my calculator and simplify it into a fraction. Math, enter, enter. It would be 67 over 36. 67 over 36. That's how many pieces. So it's like taking a semicircle, cutting it into 36 pieces, which I know this is small. I can see 36 right there. They're each going to be 5 degrees, because that's really what these numbers got divided by. 67 of them would make this 335 degrees. And so in radians, that would be 67/36 of pi, or 67 pi over 36. So we're always going to use this relationship when we're going from degrees to radians, or vice versa, that pi radians equals 180 degrees. That's our conversion factor. And so our next set of directions say, convert the following angle from degrees to radians, express your answer in simplest radical form. And so I don't know if you've learned this in a science class. We always learned it in chemistry, but it's unit, or let's see, dimensional analysis, or sometimes unit analysis. But what I'm going to do is start with my 60 degrees, and then I want to multiply it by this common ratio here. But I always want my common, what do we want to say, common terms, common, I don't want to say, I'm losing the word here, but my degrees then to be diagonal. And so I'll have pi over 180. So basically, if I'm going from degrees to radians, I want to multiply by pi over 180 degrees. You want these diagonals to be the same unit. And so then basically all I'm doing is simplifying 60 over 80, which I don't even have to do that. I know that's a third. So that would be pi, 1 pi over 3. It's a third of pi, because 60 is a third of 180. All right, next one's 165 degrees. So I would take it times pi over 180 degrees. I'm going to simplify that fraction. And it, oh, I don't think it went. There we go. 11/12. So it's 11 pi over 12. It's almost 12/12 pi. It's almost a whole semicircle, which makes sense because 165 degrees is pretty close to getting to 180 degrees. All right, 720 times pi over 180. If I take 720 divided by 180, that's 4. So I get 4 pi. And interestingly enough, if I have a semicircle that's pi, a whole circle is then 2 pi. So 4 pi would be 2 complete revolutions, or 720 degrees. Okay, what if we want to go the other way? We want to convert between radians to degrees. Well, we use the same conversion factor, that 180 degrees is pi, but now this time, since pi is in the numerator, I want to put pi in the denominator. So I put 180 degrees on top. So I'm going to do that every time. Your degrees over pi. Here, I just want to cross simplify my pi's. Then I can do 3 times 180, because I multiply straight across. That'll get 540 divided by 4, because that's 4 times 1. And that is simply 135 degrees. So 3/4 of a pi, 3/4 of 180 is 135. Okay, next one, 7 pi out of 12. That would be times, put pi in the diameter, 180 degrees on top. Pi's cross cancel. You're doing 7 times 180 divided by 12. It would be 105 degrees. Which again makes sense. 7/12 is a little bit bigger than 6/12, which is a half of 180, so it's a little bigger than 90 degrees. Sometimes we don't even have pi. Sometimes we just have a number like -4. All you need to know is that is a radian, so you still need to put pi in the diameter. Why can I not talk? The denominator, and put 180 degrees on top. And so we'll take -4 times 180, and then we're going to divide by pi. And it says round to the nearest tenth, so it'd be -229.2 degrees. So radians don't always have to have pi in it, but normally it does.